Welcome back, everyone. Let's dive deeper into some of the strangest and most mind-bending paradoxes in time travel theory. Kaori, have you ever heard of the grandfather paradox?
Of course, it's one of the most famous ones, but it still confuses me every time. Let me try to explain it simply. Imagine you could travel back in time, and for some reason, maybe by accident, you prevent your grandfather from meeting your grandmother. That would mean your father or mother was never born, so you were never born. But if you were never born, how could you have traveled back to prevent their meeting?
Exactly. It's a logical contradiction. The grandfather paradox questions the possibility of changing the past. If your existence depends on the event you changed, it creates a paradox where the timeline collapses into impossibility. And this isn't just philosophical, it challenges the fundamental consistency of causality in physics.
So basically, if time travel to the past is possible, it could destroy logic itself. That's terrifying.
It is, and some physicists believe that the universe simply doesn't allow this to happen. But before getting to those solutions, there's another paradox called the Bootstrap paradox, or causal loop, which is equally fascinating.
Bootstrap paradox? I've heard that term, but I don't really get it. Could you explain it easily for everyone listening?
Of course, imagine you find an old violin in your attic with a note saying Stradivarius 1715. You travel back in time and meet Antonio Stradivari, the legendary violin maker, and you show him this violin. He examines it and makes a replica based on it. That replica is passed down through history until it ends up in your attic, the same violin you took back to him.
Wait, so who made the original violin?
Exactly. The bootstrap paradox is about objects, information, or even people that exist in an infinite causal loop without an origin. They are never created, they just exist. Another example is in Doctor Who, when Beethoven's music exists because the Doctor brings the music sheets back in time to Beethoven, who never composed them originally.
That's wild. So something can exist without ever being invented? It just loops endlessly?
Yes, it defies our sense of cause and effect. Philosophers and physicists debate whether such loops are logically valid or violate fundamental principles like conservation of information.
It feels like reality would break if that happened.
Perhaps. Now, one way that people try to resolve these paradoxes is through the theory of parallel universes. Have you come across that idea?
I love that concept. Basically, it says that when you travel back in time and change something, you don't erase your own timeline. Instead, you create a new parallel universe where the changes you made take effect, but your original universe remains untouched.
Exactly. This avoids paradoxes because your actions don't affect your own past. In the grandfather paradox, you could go back and stop your grandfather from meeting your grandmother, but that would just create a universe where you were never born, while your original universe still exists with you in it.
That's almost comforting, but it also means there could be infinite versions of us in different universes.
Yes. According to the multiverse theory, every choice, action, or even quantum fluctuation branches into a new universe. It's a very elegant solution to time travel paradoxes, though it raises philosophical questions about identity and reality itself.
And is there any scientific support for this idea?
Quantum mechanics, especially the many worlds interpretation, suggests that all possible outcomes of quantum events do happen, each in its own universe. It's not direct proof of parallel timelines from time travel, but it shows that reality might be far stranger than we imagine.
It's scary, but beautiful at the same time. And speaking of preventing paradoxes, what about Hawking's chronology protection conjecture? I know it's about the universe avoiding these problems.
That's right. Stephen Hawking proposed that the laws of physics prevent time travel to the past at a macroscopic scale, meaning large-scale time travel like in movies would be impossible. He called it the chronology protection conjecture.
So the universe has a defense system against time travel?
Exactly. Hawking suggested that quantum effects, like radiation, would destroy any wormhole or structure that could enable time travel before it forms. It's like nature saying, no, you can't break causality.
That makes sense. If paradoxes could destroy logic, reality would need to protect itself.
Yes. And while this is still a conjecture, meaning it's not a proven law but a strong idea, many physicists believe that even if time travel to the future is theoretically possible through time dilation, traveling back to the past will always remain forbidden by the universe itself.
It feels like there's a hidden wisdom in how reality works, like it's protecting itself from collapsing.
Indeed. And that concludes our exploration of some of the deepest paradoxes in time travel theory for today. Ready to continue with our next topic?
Elian, I've always been curious about the conspiracy side of time travel. Like, are there any real-life projects that claim to have worked on this?
Oh, yes. And one of the most famous is called Project Pegasus. Have you heard of it?
I think so, but remind me, what was Project Pegasus supposed to be?
Project Pegasus is a conspiracy theory that claims the U.S. government ran secret experiments in the late 1960s and early 1970s involving time travel and teleportation. The main person behind these claims is Andrew Basiago, who says he was part of these experiments as a child.
That sounds like a sci-fi movie. What exactly did he say?
Basiago claims that the program was run by DARPA, which stands for Defense Advanced Research Projects Agency. Just to clarify, DARPA is a real U.S. agency responsible for developing emerging technologies for military use. They created early versions of the internet, for example. But, according to Basiago, Project Pegasus involved children because they were more adaptable to the physical and psychological effects of teleportation and time travel.
And what kind of teleportation or time travel did they supposedly do?
He said they used quantum access technology based on devices called chronovisors and jump rooms. A chronovisor, in conspiracy lore, is a device that allows you to see past and future events like watching a movie. The idea comes from an alleged secret Vatican device, but there's no evidence it ever existed. The jump rooms were supposedly portals that could teleport you instantly to other locations, even Mars, according to some versions of the story.
That sounds really out there. What do scientists say about these claims?
There's absolutely no scientific or empirical evidence supporting Project Pegasus. Physicists say the technologies described violate fundamental laws of physics as we know them today. But these stories remain popular because they mix real agencies like DARPA with fantasy elements, creating a narrative that feels believable to some people.
It's like blending reality with fiction so well that people want to believe it's true.
Exactly. And Project Pegasus is just one of many time travel conspiracies. Another famous time travel story from the internet is John Titor. Do you remember him?
Yes, I love that story. Let me explain it to our listeners. John Titor was an internet user who appeared on forums between 2000 and 2001, claiming to be a time traveler from the year 2036. He said he was a soldier sent back to recover an old IBM 5100 computer needed to fix computer problems in his time.
And what made his story so convincing to some people?
First, he shared detailed explanations of his time machine, which he said was installed in a 1967 Chevrolet Corvette. He also gave predictions about future events, like civil unrest in the US and a Third World War. But none of those predictions came true.
Yes, and people were fascinated because he included detailed technical details about the IBM 5100's hidden functions, which were not widely known at the time.
Exactly. That made his claims feel authentic. But over time, many people analyzed his posts,
and concluded that he probably researched the IBM 5100 information deeply before posting. And his predictions being false makes it clear he was either a troll or a creative storyteller.
Indeed. John Titor's story remains one of the greatest internet urban legends about time travel. And there are other so-called time travelers online, like the Soldier of Taured or the time-traveling hipster.
The Soldier of Taured is that man who supposedly arrived at a Japanese airport with a passport from Taured, a country that doesn't exist. When authorities detained him, he mysteriously disappeared. But many say this was just an invented urban legend with no documentation.
Right, and the time-traveling hipster refers to a 1941 photo showing a man with sunglasses and clothing that looks modern. Some people say he was a time traveler, but historians explain that sunglasses, printed t-shirts, and knitted sweaters all existed back then, even if the style looks modern to us now.
So, sometimes what we think is a time traveler is just someone with unique fashion sense.
Exactly. Now, there's a question we must address. Why don't we see time travelers if time travel is possible?
That's a great question. What are the possible explanations?
Physicists and philosophers have proposed several possibilities. One is that time travel to the past is simply impossible, as we discussed with Hawking's chronology protection.
Another is that time travelers can't go back to before the invention of time travel technology. For example, if we invent a time machine in 2100, no one could travel back to 2025 because the machine didn't exist yet.
That makes sense, like not being able to call someone who doesn't have a phone yet.
Exactly. Another possibility is rules or ethics. Time travelers might have strict guidelines preventing them from interacting with the past to avoid paradoxes. And lastly, we might have seen them, but we simply don't recognize them as time travelers.
Or they blend in so well that we think they're just eccentric people.
True.
And Stephen Hawking did a famous experiment to test this idea.
Oh, yes. The party for time travelers.
Exactly. In 2009, Hawking hosted a party with champagne and canapes, but he didn't send out the invitations until after the party had ended. He waited to see if any time travelers from the future would come back in time to attend. Nobody showed up.
That's such a brilliant and simple test. What did he conclude from it?
He said, "I have experimental evidence that time travel is not possible." But of course, it was partly a humorous way to illustrate his point about chronology protection.
Still, it's a clever experiment. But Elian, is there any sense in which we actually do see the past every day?
That's a beautiful question, Kaori. Yes, astronomy. When we look at the stars, we're seeing light that left them millions or even billions of years ago. For example, when we observe the Andromeda galaxy, we see it as it was 2.5 million years ago because that's how long its light took to reach us.
So telescopes are like time machines, showing us the ancient universe.
Exactly. In a way, astronomers are time travelers. We can never see the present state of faraway objects, only their past. And looking deeper into space lets us look deeper into time, all the way back to the birth of the universe.
That's poetic and humbling. Even if we can't travel back ourselves, the universe sends us its memories every night.
Kaori, earlier you mentioned paradoxes in time travel. But I've also heard of something called the Novikov self-consistency principle. Could you explain that?
Absolutely. The Novikov self-consistency principle, proposed by Russian physicist Igor Dmitrievich Novikov, suggests that if time travel to the past is possible, only events that are self-consistent can occur. In simple words, the universe arranges things so that paradoxes cannot happen.
So if I tried to go back and stop my grandfather from meeting my grandmother, the universe would somehow prevent me from doing it?
Exactly. Either you fail for some reason, or your actions end up causing the very thing you tried to prevent. For example, if you tried to stop them meeting and accidentally introduce them instead, the key idea is that causality remains consistent. You can't change the past in a way that would create contradictions.
That sounds like destiny. So the past is unchangeable no matter what we try.
According to Novikov, yes. This principle preserves logical consistency in the universe and avoids paradoxes like the grandfather paradox. It's a way of saying, if time travel exists, it's not like in the movies where you can change anything you want.
It feels almost like the universe has its own immune system against paradoxes.
That's a beautiful way to put it, Kaori. So speaking of paradoxes and time travel, what about all the testimonies from supposed time travelers we see online? You know, those TikTok users or forum posts predicting the end of the world every few months?
Yes, conspiracy theories about time travelers are everywhere, from John Titor to newer accounts like Time Voyager 2582 on TikTok, who claim to know future events. But there's a clear pattern. None of their predictions come true.
Why do you think people make these claims?
Many are hoaxes for attention or storytelling experiments. Some might believe their own visions or dreams are real, but it shows how deeply humans are fascinated by time travel, enough to invent stories to feel connected to that possibility.
It's like an expression of our fear and hope for the future. And these stories spread because they tap into a universal curiosity.
Exactly. Which brings us to an interesting question. Why do almost all cultures have stories or legends about time travel or time manipulation?
That's true. In Japan, for example, we have the legend of Urashima Taro, a fisherman who visits the Dragon Palace under the sea for what feels like a few days. But when he returns, hundreds of years have passed.
That's similar to the Rip Van Winkle story in the West, where he falls asleep and wakes up decades later. Or the Hindu Mahabharata, where King Kakudmi visits Brahma for a short conversation and returns to find millennia have passed on Earth.
So across cultures, there's this recurring theme of time distortion. Why is that?
Some anthropologists suggest it reflects our fear of mortality. The idea that life moves faster than we can perceive. Others say it's about the desire to escape reality, to jump into the future or past where problems are different.
Or maybe it's because humans naturally question what time really is.
Indeed. And besides myths and conspiracies, there are reports of time slips which are quite mysterious.
Time slips, what are those?
They're events where people claim to have spontaneously slipped into another time period, usually for a short duration. For example, in England, there are stories of people walking through an old street and suddenly seeing it as it was centuries ago, with people in period clothing and no modern buildings.
That's like accidental time travel.
Exactly. Some famous examples come from places like Liverpool and Versailles. At Versailles in 1901, two women, Charlotte Ann Moberly and Eleanor Jourdain, claimed they saw Marie Antoinette and her court walking the grounds as if they were still alive.
What explanations are there for time slips?
Psychologists suggest they could be dissociative experiences, where the brain temporarily disconnects from reality due to stress or neurological conditions. Others propose they are anomalous events we don't yet understand. Paranormal researchers love them as evidence for time distortions or residual hauntings.
It's like walking through a memory the world left behind.
That's a beautiful way to imagine it. Finally, there's a philosophical question we must ask about time travel. Does it eliminate free will?
That's deep. So, if I travel to the future and see myself as a teacher, does that mean no matter what I choose now, I will end up as a teacher?
That's the problem of reverse causality, or causalidad inversa. If the future already exists, and you can visit it, it implies that your actions are predetermined to lead you there. It challenges the concept of free will.
So, is everything we do just following a script?
Some philosophers believe in determinism, which says every action is the result of previous causes, like dominoes falling. Others argue for compatibilism, meaning free will can exist even in a determined universe, because it's about acting according to your motivations, not about randomness.
And what about people who believe in true free will?
They believe we can choose our actions independent of prior causes. But time travel complicates this because if you visit the future and see your fate, any choice you make now would only fulfill that vision, not change it.
It's both terrifying and comforting. Maybe it means the future is already written, or maybe seeing it just influences you to choose it willingly.
Exactly. Time travel always raises questions that go beyond science. It touches philosophy, identity, and meaning.
Elian, earlier you mentioned the many worlds interpretation. That idea always blows my mind. Could you explain it clearly for everyone listening?
Of course. The many worlds interpretation, also called MWI, is a theory in quantum mechanics proposed by physicist Hugh Everett III in 1957. Basically, it suggests that every time a quantum event happens with multiple possible outcomes, the universe splits into separate branches, each realizing one of those outcomes.
So every choice or possibility actually happens, but in different universes?
Exactly. For example, imagine you're deciding whether to have tea or coffee this morning. In the many worlds interpretation, there is a universe where you chose tea and another where you chose coffee. Both universes exist simultaneously, but never interact.
That's incredible. But what does quantum mean here? Just to clarify for our listeners.
Great point. Quantum refers to the smallest possible units of physical reality, the behavior of particles like electrons or photons, which don't act like solid balls but more like waves of probability. Quantum mechanics studies how these particles behave at microscopic scales, and their behavior is probabilistic rather than certain.
So how does this connect to time travel?
If the many worlds interpretation is true, then traveling back in time and changing something wouldn't create a paradox. Instead, your action would create a new branch, a parallel universe where events unfold differently from your original timeline.
Meaning you can't destroy your own existence by accident because you'd just be in a different universe.
Exactly. Some scientists and science fiction writers suggest that a true time machine might not send you back into your own past, but into the past of a parallel universe, avoiding paradoxes entirely.
That makes time travel feel less dangerous, but also lonely because you'd be in a world that isn't really yours.
That's a profound observation. Philosophers debate whether these parallel universes are real or just mathematical conveniences to explain quantum probabilities. But if real, they would be unimaginably numerous, creating an infinite multiverse of all possibilities.
It's beautiful and terrifying at the same time. Like thinking of infinite versions of myself making different choices.
Indeed. Now, speaking of concepts that bend our understanding of time, there's another idea called closed time-like curves, or CTCs. Have you heard of them?
Only the name. What are closed time-like curves?
Let's break it down. In physics, time-like refers to a path through space-time that a particle with mass can follow, meaning it moves slower than light. Closed means it loops back to its starting point. So, a closed time-like curve is a path through space-time that brings you back to your own past.
So it's like taking a path that leads you to the moment you started walking?
Exactly. Mathematically, CTCs are solutions to Einstein's field equations in general relativity. In 1949, the mathematician and logician Kurt Gödel discovered such a solution. He described a universe filled with a rotating fluid that creates conditions allowing these closed loops in time.
Wait, Kurt Gödel? Isn't he the one who made the incompleteness theorems in mathematics?
Yes, the very same. He was a brilliant thinker who worked with Einstein at Princeton. While his rotating universe solution was mostly a theoretical curiosity, it showed that general relativity does not strictly forbid time travel to the past.
That's incredible. But wouldn't traveling on a closed time-like curve create paradoxes, like the grandfather paradox?
It could, unless the Novikov self-consistency principle we discussed earlier applies, preventing any action that creates inconsistencies. However, CTCs remain purely theoretical because they require conditions that don't exist in our universe, like an infinitely rotating cylinder of mass or certain exotic energy distributions.
It feels like the math says it's possible, but reality says no.
Exactly. It's like general relativity opens the door, but quantum mechanics and physical practicality shut it again.
Still, it's beautiful that the universe allows such possibilities, even if they're unreachable for us now.
Indeed. Now, related to CTCs is the concept of causal loops, also known as bootstrap paradoxes. This idea is fascinating. Do you want to start explaining it, Kaori?
I'll try. A causal loop is when an event causes itself in a closed cycle. For example, imagine a woman receives a physics book from a time traveler. She studies it, becomes a great physicist, and then one day travels back in time and gives her younger self the same book.
Exactly. So where did the book originate?
It has no true origin. It exists in a self-contained loop.
That's the mystery. Causal loops are troubling because they defy our intuition that every effect has a cause, and every cause has a prior cause. In these loops, the cause and effect sustain each other infinitely.
So, can an object or information exist without ever being created?
Philosophically, it challenges the principle of sufficient reason, which says everything must have a reason or cause. In physics, causal loops could exist mathematically, but whether they are physically possible is another matter.
It almost sounds like time itself is bending reality to sustain its own consistency.
Yes. These loops often appear in fiction as mysterious artifacts with no origin, but in theoretical physics, they show up in models with closed time-like curves or certain wormhole solutions. However, many scientists believe quantum effects would prevent them from forming in reality.
Because if causal loops existed freely, wouldn't they break the laws of thermodynamics or conservation of energy?
That's a great point. Creating objects or information without origin could violate conservation laws. But in theory, since the loop is closed, the energy or information is never actually created or destroyed. It just exists in an eternal cycle.
That's such a profound concept. It makes me wonder if the universe itself could be a causal loop, existing because it causes itself. Elian, as we reach the end of today's journey, there's something I keep thinking about. All this talk about time travel, wormholes, causal loops, paradoxes, but what if time itself is just something our minds create?
That's a profound question. Many philosophers and neuroscientists believe that time is a construction of consciousness. In physics, time is treated as a dimension, a coordinate like space. But our perception of time, the feeling of past, present, and future, is something our brains assembles.
So, time as we experience it is not out there, but in here, inside our minds?
Exactly. For example, the psychologist William James described time as a stream of consciousness, always flowing but built moment by moment in our awareness. Neuroscientists studying patients with brain injuries find that damage to certain brain areas can distort time perception, making seconds feel like hours or vice versa.
That explains why moments of fear feel endless and moments of joy pass in an instant.
Yes, and some philosophers like Immanuel Kant argued that time isn't an objective property of reality, but a framework our minds impose to structure experiences. Without consciousness, there would be no now or then, only the timeless unfolding of reality.
That's beautiful. And it makes me wonder if time travel ever becomes possible, would it be a machine outside of us, or would it require altering our consciousness itself?
An excellent question, Kaori. Speaking of machines, there's one last concept I want us to reflect on: negative energy and exotic matter.
We've mentioned exotic matter before with wormholes, but what exactly is it?
In physics, exotic matter refers to hypothetical materials that have properties opposite to normal matter, like negative mass or negative energy density. For example, to keep a wormhole open for travel, you would need negative energy to counteract gravity's collapse.
But does negative energy really exist?
Quantum physics suggests that negative energy densities can exist in small amounts. The Casimir effect, for example, shows that vacuum energy between two very close metal plates is lower than outside, creating a kind of negative energy zone. But these effects are microscopic and short-lived.
So, using them to build a time machine is far beyond our capabilities for now.
Yes, for now. Some physicists argue it might be fundamentally impossible to harness enough negative energy to stabilize a wormhole or warp bubble. Others think future breakthroughs in quantum gravity or new physics could reveal ways we can't even imagine today.
It's humbling to realize how much we don't know. Time travel might remain a dream, or maybe it's a truth hidden beyond the edges of what we call reality.
Exactly. And maybe that's what makes time so beautiful. Its mystery gives meaning to our fleeting moments.
So, to everyone listening, do you think time travel is possible? Is it just science fiction, or is it a destiny we haven't reached yet? Let us know your thoughts in the comments.
And if today's journey through time, paradoxes, and consciousness made you think, smile, or question reality, give this video a like. It helps us keep exploring deep topics with you.
Don't forget to subscribe to Polyglot Talks for more conversations that combine science, philosophy, culture, and mystery. Tell us what you thought of today's episode. What was the concept that amazed you the most?
To summarize today's journey, we explored the possibility of time travel, paradoxes like the grandfather paradox and causal loops, parallel universes, the construction of time in our minds, and the physics of exotic matter and negative energy. The universe is far stranger and more beautiful than we ever imagined.
Thank you for being part of this journey with us. Until next time, keep questioning, keep wondering, and remember, we're all time travelers, moving forward 1 second at a time.
Goodbye, everyone.
Bye-bye!